240 before we start. It's relatively easy stuff, right? You're basically just doing some basic arithmetic or plugging stuff into a calculator. It's not so much to do. But if you change your mind later, that's okay. But given a few minutes for people to look and nobody's like beating down asking me questions. If Mackenzie's shaking her head no, I know there aren't any questions. So, not that you're bad at math, you're very good, but you like to ask a lot of questions because you want to be sure, and that's great. But I can usually, if Mackenzie's not asking any questions, there's no real. Oh, humble too. All right. Okay. So yeah, Tyler. Can you do 37? Yeah, man. We can do that. Let me just pull up the problem. And if I sat there and shuffled in place long enough, somebody was going to take me up on it. Okie dokie. And here we're just asked to put it in standard form. Leave the answer exact if possible, and if not, we'll round to 2 decimal places. I look at this, I notice that 68 degrees is not a unit circle angle, so there is no exact way to do this for us. So I'm going to go straight away to calculator time. So I'm going to do 12 times cosine of 68. Got to make sure I'm in degree mode because these angles have degrees on them. So there's my x coordinate, or my real part, I guess I should call it. And then 12 sine 68, there's my imaginary part. So I have what? 4.50 plus 11.13i. That's it. Nothing to do, just basically a calculator problem. You probably knew that, but you're just checking, right? I think that's the first one that's like totes a calculator problem. I think the other ones before that, you're using the unit circle to do things exactly. Okay, that sounds good. Today, we're going to do the very, very challenging section 11.2. I'm just kidding. It's not really challenging. It's not really any more difficult than what you did in section 1. So, that's okay. So this is about multiplication and division of complex numbers. So we did a little bit of this last year. So let's say that we had 2 complex numbers in standard form and we're multiplying them together. This was a problem that we did last year in Algebra 2. What do we do to multiply those 2 things together? Yeah, we just FOIL that stuff out. So 2 times 5 is 10. 2 times negative 4i is negative 8i. 3i times 5 is 15i. And 3i times negative 4i is negative 12i squared. And what's I squared equal again? Negative 1. So when I combine like terms, I really have 12 plus 10, so 22, and then plus 7i. Everybody okay there? Now, what if I wanted to do this multiplication problem in trigonometric form? Well, let's say we have 2 complex numbers. I'll call them Z1 and Z2. Where Z1 is R1 times cosine theta 1 plus I sine theta 1, and Z2 is R2 times cosine theta 2 plus I times sine theta 2. So if I multiply these two things together, I got like something that's going to look like this. Is everybody okay so far? So nothing big deal, like, all right, you just define two complex numbers in trigonometric form and then wrote them so they're multiplying each other. Whoop-de-dee-doo! When you look at this, is there any real reason those brackets need to be there? Oh, my goodness. Guys, I need to put a parenthesis here and here. Goodness, great googly mooglies, guys. That was a big boo-boo by Mr. Kulik. Anyways, before, yes, the answer would have been, yeah, those brackets need to be there, but not after I made that mistake and those parentheses really. So now, if I ask you the question, do those brackets need to be there? No, man, right? Because all we really have are just four things being multiplied together, right? R1 times that parenthesis, R2 times the other parenthesis. Everybody agree there's four things? R1 parenthesis, R2 in parenthesis, that's four things. Since they're being all multiplied together, I can multiply them in any order I want, correct? So I'm going to multiply the R1 and R2 together out front, and then I'll leave the other stuff together. Everybody coolio there? And, well, I guess I got those two parentheses next to each other. Guess what I'm going to do? Nobody has a guess? These are bad guessers. Well, FOIL them, right? That's what you usually do when you have two parentheses with a, like, expression inside of it. Got to multiply that stuff out. Okay. So I have cosine theta 1 times cosine theta 2 plus I cosine theta 1 times sine theta 2 plus I sine theta 1, oops, got the 1 there, cosine theta 2, then plus I squared sine theta 1 times sine theta 2. Yowzers, Mr. Kulik. Well, don't panic. So remember, I squared, what's that the same as? -1. So what I'm going to do is I'm going to regroup these things together. So I'm going to group together the things without the i's in it. And I'm going to group together the things with the i's in it. Oops. Put an I there. I'll do just like that. If I look at that first quantity, does that look familiar? What do you guys think? Well, Mr. Kulik's asking me if it looks familiar, so it probably is something, right? Guess what that is? That is an identity. Which identity is it? That is the cosine, or the sum of two angles for cosine? What? And take a look at that second quantity. Does that look familiar? Well, Mr. Kulik's asking me, so the answer is probably yes. It is. That's also an identity. That's the sine of the sum of two angles. Whoa, whoa, whoa. That's a pretty stinking nice formula. What's that saying? If I want to multiply two complex numbers in trigonometric form, I just multiply the r's together and I add the thetas together. Boom, done. What? So if I wanted to do this as a multiplication problem, so let's say I have the two complex numbers, 4 times cosine 172 plus I sine 172. And the second one, 7 times cosine 13 plus I sine 13. If I want to multiply these two together, I just do 4 times 7, cosine 172 plus 13. And then I sine 172 plus 13. Or really, 28 times cosine of 185 plus I sine 185. Done. Mr. Kulik, that's basically a mental math problem now. Woo, doggy, that's easy. Right, what are we talking about here? Like some whole number multiplication, some whole number additions? Mr. Kulik, I can handle that stuff right there. It's even easier than it was in standard form, right? That's the advantage here, the trigonometric form. The operations are super easy. Which is pretty righteous, you know? Should we talk about division? You guys think you got that? Right? Just like a formula, just using a formula. The formula is super easy to use. All right. Let's move it then. So let's talk about division of two complex numbers in standard form. So let's say I have 3 plus 5i divided by 8 minus 2i. The way that we want to think about this is really just as a fraction. So we'll think about it like that. Again, just divisor over dividend. Nope, dividend over divisor, excuse me. It's the end of the day, man. Cut me some slack. Cheapers, creepers. You make a mistake once and nobody will leave you alone about it. All right. Who remembers what do I need to do this division? Basically, the goal is I want to end up having a complex number at the end. So what do I got to do? Got to get those i's out of the denominator. Does anybody remember how we accomplished that?
I don't know, but I know I was scared of the one.
That's a fact. So we got that I in the denominator right now, right? I'll give you a hint. I'm going to multiply the top and bottom of this fraction by something. Jackson.
You multiply it by 8 plus 2i over 8 plus 2i.
Yeah, there you go, buddy. So when I have something like 8 minus 2i and I have something like 8 plus 2i, what do we call those things? There's a math term for things like that. Those are called conjugates. So the instruction that we'd say is that we multiply by the conjugate. So in the numerator, I'm just going to FOIL that out. Everybody cool there? And in the denominator, I could FOIL this out manually, but what else do I notice here in the denominator? What I notice is that I have like a minus b times a plus b. And from last year, I recognize that pattern as the difference of two squares. So I'm going to use that factoring pattern to make the multiplication that much easier. So it's just going to be 64 plus 4. Wait a minute, Mr. Kulik. Why is it a plus instead of a minus? Because the I squared is the negative 1, so I'm just simplifying that step there. Is everybody cool? We see where the plus comes from. Again, if you're doubting yourself, you can always FOIL it out by hand. You'll get the same result. I'm just saving us some time, you know, my dudes? Time. It's on my side. So remember, I squared is... You didn't say it that time, guys. Thank you. And then I got 6 plus 40, so that gives me 46i all over 68. And I can reduce that. So if I divide both by the top and bottom by 2, I get 6 plus 23i over 34. Oops, forgot that I. And probably the better way of writing it, if we're going to be super technical, is writing it like this, where we can see the A and B. So it just looks like A plus BI. And I recognize the A, we could reduce some more. Yes, you should do that. Mia. 24, oh, it should be 14, huh? Is that what you're saying? 24 minus 10. But yeah, you're right. 12 wasn't the right number there. Arithmetic is hard, guys, especially after you've been like working hard all day. And then you just like booger some trivial mental math like 24 minus 10. It's kind of embarrassing. I make arithmetic mistakes all the time and my wife gets so mad at me. She's like, how are you screwing up the tip? I'm like, I don't know. Just it's not really interesting to me, so I'm not trying very hard. I just made a mistake. Like, I was looking at it and I knew I made a mistake at least, and I was just like, what are you doing? It's like, I'm just making mistakes here. It's okay.
Yeah, in the fourth hour, just like the whole entirety of the frontal lobe starts to put that.
Yeah. You guys remember doing this? We did this last year, so hopefully that rings some bells. Now, what if we want to do this in trigonometric form? let's see if we can just plausibly come up with the formula without actually having to do the derivation that we just did, which again, we could do. It's not that difficult of a derivation. It's really almost identical to the one we just did. But I think if you put your thinking caps on, we can come up with the formula without actually having to do the derivation, which is what I'd like to do. Jackson.
Same as the other one, but you're just subtracting.
Okay, so you're very close. So I agree that we're going to be subtracting the angles. But what are we going to be doing to the r's? Dividing them, yeah. Not multiplying. But again, like, woo! That is a nice stinking formula, because guess what this turns into now? It's like a mental math problem, right? Let's do an example, make sure we got it. God bless you, times 2. All right, so let's say it's cool, like you're forgetting parentheses again. I know, I was going to remember them. Get off my case. I'm just joking. You can stay on my case. If I'm making mistakes, don't let me make mistakes. That one I saw, though, and I was in the process of fixing it. I just was finishing what I was writing first. All right. So there's my two complex numbers, 14 times cosine pi over 3 plus I sine pi over 3, and 2 times cosine pi over 7 plus I sine pi over 7. All right, so I'm dividing these two numbers. What do I write? Well, 14 over 2 times cosine of, yes, sir. Yes. I thought somebody was going to volunteer an answer. I was excited. Mackenzie!
Pi over 3 minus pi over 7 plus I sine.
Yes. Now, what's the only hassle here? To subtract those fractions, what do we need to have? Common denominator, which would be 21. So what do we get? We get 7 times cosine of 4 pi over 21 plus I sine 4 pi over 21. Still pretty much a mental math problem, right? Is everybody happy with what we did? Made a common denominator between pi over 3 and pi over 7. So I multiplied pi over 3 by 7 over 7 and pi over 7 by 3 over 3. Same problem really as 1 over 3 minus 1 over 7, and then just put a pi on with the numerator. That helps any? No? Maybe? Some of us? How is this? Hard, easy, medium? Pretty easy.
Medium well.
Medium well. Drake's cooking a steak over there, apparently.
I'd say the but just understanding multiplication though is that like rare. Rare is pretty good for just because like there's just so much going on.
The point of that was just getting the formula, though, man. All you need is the formula.
No, rare things really.
I
think the correct word is weak. No, rare is so good.
I just want to point out to you guys that on either of these two examples in trigonometric form, once you've done the multiplication, we can then easily convert that into a standard form answer if we wanted to, just with our calculator, right? In either of these problems, it's pretty trivial to take that to standard form, correct? So the point of what we did today was to illustrate to you that the multiplication division operations are really easy in trigonometric form, and the conversion out of trigonometric form to standard form is really easy. If you wanted to, you could do, instead of like having to do foiling and multiplying by conjugate, you could convert your standard form problems to trigonometric form, do the operation trigonometric form, and then convert it back out to standard form at the end. And that's a reasonable thing to do as well. And if you were designing like, or you had a situation where you had to do lots of operations on complex numbers, that's probably what I would do, is I would just convert everything to trigonometric form, do all my operations in trigonometric form, and then convert back out to standard form. Certainly if I was designing like a computer program to do that, because that's, probably the complex number operations would be defined already for you in the computer program. But if they weren't, much easier to track what you're doing in the with the trigonometric form using that formula. And that's it for section 2. That's all there is. You're just using those, working on those 2 operations. We're going to stop there, mostly because section 3 is the big section, and we just took a test. I don't want to cram this all down your throats and and end up taking a test like a day from tomorrow or something, and they're just kind of a hassle. To get ready for that again, we haven't even had the homework quiz yet and all that jazz. So you guys should be able to do up to 64 now. If you've already done 1 through 40, you're looking good. Probably no problem knocking out these next 24 problems or something here before we go, particularly since most of these are just like mental math or like easy calculator problems. If you haven't started 1 through 40, maybe get a jump on that so you're ahead for the weekend. And come Sunday, you're not like, oh my God, I got to get that math homework done. And just be like, yo, I'm just going to sit back and watch some TV because my math homework is done. And I know kids don't watch TV anymore. You watch TikTok or some stupid thing. But I'm an old man, so I'm going to yell at a cloud now. Hey, you clouds, get off my lawn. No?